इसके लिए भी अच्छा जाएगा।
2 मिनट बाद कर लीजिएगा सर, फिर ज्वाइन कर।
Sir, good afternoon.
Very good afternoon, sir. Namaste. How are you? It's a long time seeing you, sir.
Okay. So shall I upload my PPT?
Yeah, you have to pin in.
Can you see my screen?
Yeah, I can see. Now you can unpin. Now you can unpin, Professor,
Okay.
so that we both are seen.
Okay.
Okay. The system would be
Please.
something like this, Professor. Give a formal introduction to you.
Okay.
And then you will take over from me with your presentation. At the
Okay.
end of the day, end of the session, we will have questions from audience,
Okay.
which can come on the link itself.
Okay. Okay.
Fine, Professor. Shall we
Okay.
go ahead?
Yes, please.
We are on air.
Okay.
Audible, public. Can you speak something, Professor? Let us check
Yes,
up the
yes.
public audio. You can speak something so that we can check up the public audio.
Okay. Inviting me 5 days. Is it okay?
Is it okay?
Webinar series.
Just 2 more minutes, you can continue speaking.
Okay.
We'll check the public audio.
First of all, let me thank our Chancellor for getting this opportunity.
Done, sir. Done. We are through now.
Yes. Okay.
Shall we start the
yes, please.
Very good afternoon and welcome you all. We are on the 5th day of 5 days webinar series 5. As in the past, we are trying to give the best of best webinar series from our end. Many eminent speakers have come and participated, and today it has gone international. And I'm thankful to the alumni for taking this feat. Over and above, I wish to put my sincere thanks to our Vice Chancellor in charge, Professor B. Subraj, our Chancellor, Dr. K.M. Annamalai, and our Registrar, Shri Dr. V.P.R. Sivakumar, for giving us this opportunity to run it successfully with all the supports whatsoever is possible from our parent institutions side. As in the past, today we have a very distinguished guest, Professor Abraham John, a very well known personality in Gandhigram circle, and has an international reputation of various patents, papers, publications, so on and so forth. The University of Stanford had come up with top 2 percentile of eminent scientists in the country. We are proud. We have 7 members from our institution in that elite list. Our Chancellor wished to bring all these eminent people, showcase them with pride. So, with real pride, we all are we are all going to listen to Professor Abraham Jan on low-cost carbon nanomaterials for sensor application. This is the subject of today. To introduce Professor Abraham John, his present position is he is professor in Department of Chemistry. Sir has done his PhD from Madurai Kamaraj University, Doctor of Engineering from Tokyo Institute of Technology, Japan. Teaching and research experience is almost 21 years now. Teaching 18 and research 21 years. Areas of research of interest is development of optical and electrochemical sensors using metal nanoparticles, carbon nanomaterials, graphene, carbon dots, graphene quantum dots, nanocomposites, metal organic frameworks, fuel cells, and supercapacitors. Sorry. His PhD guidance, he has guided 18 people and still he's continued to guide 6 people. Sir has completed his research projects, that is 7, DST2, UGC2, DPT, DRDO and CSIR. 120 lakhs ongoing. He has done a project worth of 120 crores, 120 lakhs. Ongoing projects are 3. That is from DST, ACRB 34 lakhs, DBT 23 lakhs, DST, IDP 17 lakhs. Sir has referred journals and publications 168 international and 161 international and national 7. And the citations are very high, 4,350 Google Scholar, 3129 in Scopus Index. Impact factor in the H index is average impact factor is 4.27. In an H index is 35. Google it is 35, 33 in Scopus. Books and chapters published are 3. Awards, he has got awarded UGC Mid-Career Award under Chemical Sciences in 2020. Tamil Nadu Scientist Award, TANSA, for Chemical Sciences in 2012. Monbushu Research Fellow 1996 from Government of Japan. JSPS Postdoctoral Fellow 1999 from Government of Japan. JSPS Invitation Fellow in 2006 of Government of Japan. JASSO Fellow, Tokyo Institute of Technology in 2012. JSPS Short Term Fellowship in 2014, Government of Japan. His recognitions are sensors developed for folic acid, paracetamol, melamine, highlighted in Nature in India. Reviewer for ACS, Elsevier, Wiley, RSC, and Springer journals. He is mentor in DST Inspired program. His membership in scientific bodies. He is a member in Central Academy for Science and member of CSRA, Bangalore Life member for ISEAC, Mumbai, Life member SAEST. Selected recent publications are ACS Sustainable Chemical and Engineering 8, 2020, 2640, Colloids and Surfaces A591 in 2020, 124551 in Electrochemia Acta 354 2020, 136673 Sensors and Octours B 313 2020 128033 Biosensors and Bioelectronics 133 2019 48-53 Analytical and Bioanalytical Chemistry in 2019. With his kind of knowledge, I am sure the students are enriched in Gandhigram Road Institute in Chemistry Department. Not only in Chemistry Department of Gandhigram Road Institute, internationally he has earned a very, very, very high level of reputation among the peers. And I welcome you, Professor John Abraham. Welcome to this webinar series. Over to you, sir.
Okay, thanks, Dr. Krishna Kumar, for your introduction. I know it's odd time, probably those who are in north side, maybe they would have finished their lunch.
Absolutely.
But those in the down southwards,
they are hungry, waiting.
But anyway, so I'm sure that I'll not sleep you, let you. Okay. So first of all, let me thank our Chancellor for giving this opportunity, this type of platform, in the international level. I appreciate Dr. Krishna Kumar and his team for arranging this type of lectures. I also thank our Vice Chancellor in charge, Dr. B. Subraj, and the Registrar, Dr. B.P.R. Sivakumar, for their encouragements. Okay. So now, without wasting the time, let me go to the lecture, what I'm going to uh, present today. So the title which I have given is Low Cost Carbon Nanomaterials for Sensor Applications. Okay, so brief introduction about what I'm doing in Gandhigram for the last 2 decades, close to 2 decades. So I started working on synthesis of metal nanoparticles, particularly gold, silver, platinum, and touch these nanoparticles on different substrates. Then we prepared fluorescent materials that again from metal nanoclusters for sensing of toxic and biomolecules. Then we have also worked on graphene quantum dots for the last 5 years, and right now we are also working on metal organic frameworks, uh, covalent organic frameworks for energy and sensing applications. Okay, so if you look at the whole world, non-communicable diseases and their causes. If you look at the center part of this is cancer. Okay, so cancer, if you look at the root, maybe the usage of tobacco. Okay, so of course there are several reasons for having a cancer. The next is diabetics. Okay, there is a right now it's a people are every day, but diabetics patients are growing worldwide. Then in addition, we have some chronic respiratory diseases, particularly now in North India, particularly in Delhi. So we have air is contaminated. Okay, so we have very poor quality of air. Okay, then people are also facing cardiovascular diseases, the other non-communicable diseases. So if you look at the cause, the root for all these diseases, sometimes physical inactivity. Okay, so physical inactivity is the main cause for the diabetes. Then unhealthy diets. Okay, that also leads to sometimes stomach cancer. It is mainly from unhealthy diets. Then of course usage of alcohol, obesity. There are several issues. Okay, so the World Health Organization, they have an action plan from 2013 to 2020. Of course, now we are almost at the end of 2020. There are 6 global objectives. They make it as during this period to make prevention and control of these non-communicable diseases a priority and strengthen national capabilities and leadership, reduce modifiable risk factors, strengthen health systems, promote high quality research, monitor trends of diseases. So, strengthening the health system. Okay, so that is a, if you look at particularly in India, we have still long way to go to strengthen. Even though government of India is proposing several schemes, still some of the facilities not reached to the people, poor people. So here, if you look at how to strengthen these health systems, so that is where we started working on this area, and also the last one, monitor trends of disease, how we can detect the disease in early. Okay, so here comes a point of care testing. So what is this point of care testing? So one can test himself, okay, or herself to identify, okay, to detect the compounds which are responsible for the diseases. Okay, so it's at the point at which maybe from the bedside, when in the morning you are waking up and taking a sensor to detect, say for example, I want to find how much concentration of glucose today morning. Okay, how much concentration of uric acid, so that one can make a decision whether I am a diabetic or non-diabetic, or I am in the border range. So that is what point of care testing. Then take appropriate action which will result in improved health outcome. So one can analyze himself whether I was affected by cancer, or whether I'm affected by a disease called gout due to excess of uric acid. So he need not go to the hospital. Okay, he can detect himself. Okay, he can do the analysis. Okay, so that he can decide. Okay, so I am in the borderline, then I have to change my diet, or I am in the severe, the severity of the disease maybe. So you have to go to the hospital immediately. So you can decide yourself. That is the idea of point of care testing. So here come the sensor. Okay, the sensor which we are using, we are everywhere now. Now sensor starting from your home appliances and your vehicles. So everywhere you can find a sensor. Okay, so sensor is nothing but a device which contains an active sensing material with a that signal transducer may be the outcome of your whatever the device, whatever the active sensing material consumes, then it will give the signal as most probably it may be a optical signal, that is a color, or it may be a electrical signal, or it may be a thermal signal. Okay, like when you go to the departmental store, the automatically the door is opening, so that is based on the thermal sensor. Okay, so these two important components in sensor, one is your active sensing material, then another one is signal transducer. So these two components are very important in sensor. So how you can make these active material, sensing material is selective to a particular compound. Okay. So if you look at your blood serum, okay, the serum contains n number of compounds. Okay. Suppose if you develop a sensor, okay, that must be selective to one compound. Okay. Say for example, I have a disease, Parkinson disease. This Parkinson disease is due to the excess of dopamine. So I want to find the concentration of dopamine. Okay. So, but in your blood serum, you have many other compounds like ascorbic acid or uric acid, xanthine. There are so many compounds. But I want to detect only the concentration of dopamine. In that, how you can make a sensor? That is where your chemistry coming into the play. Okay. So why people want to analyze even nowadays? Those days. Look at particularly in southern area, even at the age of 80, 90, they never go to the hospital. Okay, they will do everything at their home because most of them have physical activities. They go bed very early. They wake up in the morning, early morning, 4 o'clock. So they will do whatever the physical activities the every day. But now the lifestyle is changed. People are go very late bed, then wake up very late. That is where. So even at the age of 30, 40, now we are seeing many people have problem with heart diseases or diabetics. Okay, so the urgency in analysis is, if you go to the clinical lab, okay, again nowadays relatively the time consumption in clinical lab is less, but again during this pandemic period, even we are afraid to go to the hospital because of this COVID-19. So if you have a sensor on your hand, you can detect yourself whether you are affected by some disease. Okay, that is a one thing. Then if you go to the clinical laboratory, the analysis are expensive. Okay, if you even analyzing your blood sample, cholesterol, and other compounds like creatine or urea. It all comes around 500 plus, sometimes 1000 rupees. It all depends on the laboratory or hospital. So one is expensive. The second point is time consuming process, and sometimes mismatching of samples. Okay, mismatching of the results. Okay, you may be non-diabetic, but because of the mismatching of the samples, you may be diabetic. Okay, so all these things leads to there is urgency in analysis of these compounds. Okay, so whatever you develop a sensor, it must be sensitive, first point. Then it must be accurate, and it can be able to determine at different substances, particularly the real samples like your urine, whatever the human fluids, your sensor must detect. Not in the laboratory level, it must also extend to the your clinical level. So of course, there are so many methods are followed in the laboratory level. We have spectrophotometry, titrymetry, chromatography, fluorimetry, electrochemical. If you look at all these techniques, again, you need a very good technician, uh, knowledge in the particular instrument. But if you look at the last technique, electrochemical or your spectrophotometry, even a layman can easily do the all experiments. Okay, so that is where we are concentrating on the two easy methods, electrochemical and spectrophotometry, because the first point is the time consumption is less, then it's a low cost. Then you can also achieve high selectivity, sensitivity, and simple procedures. Okay, so when you go for medical diagnostics, generally doctors mainly, whatever they are giving, prescribing drugs based on your testing only. So the testing needs rapid, it must be very fast, it must be cheap, and also involving low technology. Okay, it is generally done by technicians in the laboratory level. But now, after the introduction of successful introduction of many sensors in the market, now people they can themselves they can analyze some of the compounds, like the best right now, one of the best available sensor in the market is pregnancy test. Okay, you just take a strip that is available in the medical shop,
Absolutely.
take the urine into the strip. Based on the change in the color, you can say you are a pregnancy. You can confirm the pregnancy. That is the easiest sensor available in the market. Okay, so of course, some needs for in vivo operation and other things. That's not the another right now in the market available sensor is glucometer. Okay, there are so many companies now producing glucometers. Okay, so this glucometer also mainly based on the electrochemical principle. Okay, so here we are using enzyme. Okay, the enzyme is glucose oxidase. This enzyme is used mainly used to sense your glucose level. Okay, so here, I don't know how many of them seen this glucometer. You have a strip separately available. Then there is a small meter. Okay, you just put a pinch of blood onto that strip. Then just insert to a meter, that is glucometer. Then probably within a fraction of times you will know how much glucose present in your blood. Okay, so I don't want to go into the detail. Generally people used to sell, say, your fasting sugar is higher than 90 or higher than 120, you may be in the borderline. Suppose your fasting sugar is 200, then you are diabetic. Okay, so I don't want to go the different companies involving, and but most of the time, what is my observation? What is our observation from our laboratory? Mostly these glucometers giving the values of at least 10 to 15% error. Mostly it will give only excess concentration of glucose. Okay. So based on this principle, we developed several sensors. I will go next. So equally, we are also working on detection of heavy metal ions and pesticides. Okay. So that is another area which we are concentrating in Gandhigram. So one area which I am concentrating is the uh, developing sensors for diseases, okay, for biomolecules. The another aspect which we are concentrating is developing sensor for heavy metal ions and pesticides. Okay, so just I put it some of the pictures for your reference. If you look at endosulfan, okay, so still I think in Kerala, not only in Kerala, many states, even though they banned the endosulfan, but illegally many people are using endosulfan. Okay, so this is a image of this nanoparticle, silver nanoparticle. Okay, so just nano means the size is in the nanometer range, 1 to 100 nanometer range. So if you look at the synthesized nanoparticle are spherical in shape, the size is around less than 10 nanometer. But when I add many metal ions to this silver nanoparticle, the particle size remains same. But if I put mercury 2, then the particle size increased. Okay, so this we used to say aggregation. So now the yellow color becomes colorless. So instead of silver, I have taken gold nanoparticle. So again, when I add gold nanoparticle, when I add mercury 2, it becomes something like a black color. Okay. So gold nanoparticles red in color, silver nanoparticles yellow in color. When I add mercury 2, the color changes. But if I add any other metal ion, the color remains same. Okay, this is what selectivity. Just I don't want to give the mechanism. You just I have shown here. I have just taken this gold nanoparticles solution. So this red color is gold nanoparticle solution. Then I have added many metal ions: sodium, potassium, calcium, magnesium, iron, cadmium, chromium, zinc, cobalt, nickel, copper, iron. The concentration which I have used is something like 5 millimolar concentration. There is no color change. But if I add very, very low concentration, I can say 50,000 fold less concentration of mercury 2, you can see the color is changed to black color. So this is what selectivity of the sensor. Okay, so I have synthesized silver and gold nanoparticles. It can selectively detect only mercury 2 ions. If you look at all other metal ions, the color remains same. So whatever your sensor developed in the laboratory, that is the main criteria. Now suppose I am going to a industry, I am collecting the sample. Okay. So the industry is involved in manufacturing vessels comprising, say, for example, copper, nickel, chromium, iron, mercury. So now I want to find mercury concentration, how much? Okay, I can use the sensor because the sensor can detect exclusively mercury too. It will not sense other metal ions. This is again based on the chemistry. Okay, if you look at, so I have a this gold or silver nanoparticles capped with some compounds. So this compound is very specific with the mercury too. Okay, if you add all other metal ions, there is no such strong interaction. But if I add mercury too, there is a very strong interaction. Okay, so using these nanoparticles, I can able to detect mercury too selectively. Okay, so we heard that this Kodaikanal lake is contaminated with mercury too. Of course, we collected, but the collected area we didn't find the mercury too. So those who are interested, we want to go for the synthesis because again, this is a heterogeneous group. It's not the audience is only chemistry. So I don't want to put all chemistry. So those who are interested, you want to know how you synthesize the silver nanoparticles or gold nanoparticles, just note down this references. One paper published in Journal of Hazardous Materials, other work published in Analyst. Then another one toxic compound which we have developed sensor is melamine. Okay, so this melamine, it contains three amino groups. Okay, so generally in a milk products, we want to show that the milk product contains amino acids. Okay, so the quality or the milk products are generally analyzed based on the amine groups. So in China, 2008, in the month of October, okay, so many kids, they are all after drinking this milk, mainly the milk powder made into milk. So when they taken this milk powder, the kids are started vomiting. Okay, and also there are several issues. Then it was found that the milk powder was adulterated with this melamine. Okay, so actually this melamine is used to make this type of materials. We have the pet bottles. Okay, then we have nice plates. Then including we have babies, many plastic wares, and you can make use of resin. This melamine combined with the resin to make all these materials. Okay, so for this deduction of this melamine, we have synthesized again gold nanoparticle, but with different different compound. Okay, so again, if you look at the color of the gold nanoparticle is red, but when you add this melamine, it becomes violet color. Okay, so again the particle size is increased. Now, just we have checked whether the products available in our market is it adulterated with this melamine. Fortunately, you can see the Cerelac, different products, and including the cow milk. You can see they are free from this melamine. Okay, so fortunately, our milk products are not adulterated with this melamine. Okay, so this is a very simple technique. Just take, that's what I said. Even a layman can detect easily whether my milk product is contaminated with this melamine. Okay, just take this gold nanoparticle solution, add your milk powder. If there is a color change, then you can say yes, it is contaminated. Okay, of course, if you want to exactly find how much concentration of this melamine, then you have to go for a instrument. You need an instrument. Okay, so that's what you can just deduct whether mercury is present, whether this melamine is present. For quantitative analysis, then you can go for the analysis. Okay, so if you look at the samples which we have collected, they are all free from this melamine, of course. So when we, of course, those days we are unaware of all these patent and the things. Actually, it was around 2008 or 2010, most probably 2008 or 10. Okay, so those days, of course, now we have a patent cell. GRA has a patent cell, so you can make a patent. Those days we don't have patent. So the moment we published, a company from Germany, uh, they have a branch in Bombay. So they called me and they asked, sir, how you done this experiment? We are very much interested. Then I said, we'll make some collaboration and other things. By the time this work was published, so probably they got
Sold
all
out.
these features. Most probably they are now using. I have no idea. So Actually, this work was highlighted in Nature. So Nature is highlighting now. Nature is publishing from each countries, well, like whatever the works highlighted or whatever the works important. So they will highlight in the publications. Then another important toxic compound is bisphenol A. Okay, so this also mainly this bisphenol A is involved in making many uh, plastic cups, then plastic bottles. Okay, so what is the problem with this bisphenol A? If you consume this, there are so many cancer listed. Okay, so you can see there is a possibility of breast cancer, prostate cancer, the miscarriage and birth defects, effects on fertility. There are so many issues. Okay, so we have developed again based on the solution-based sensors for this compound. Just here we have again synthesized gold nanoparticle using bovine serum albumin. Bovine serum albumin capped this nanoparticle. So when we add this bisphenol A, very low concentration, immediately the color changes to violet. Okay. So everyone looks, the this guy is telling always when you have red color, when you add something, you will get. These are all very specific. No, of course, these gold nanoparticles. Why there is a color change? Since their size changes, the color changes. That is the concept. Okay, that's what I said. I don't want to go into deeper in the chemistry. Okay, so when you add, suppose you are asking, or suppose if I add mercury 2 to this solution, no, because I have used a different stabilizing agent, bovine serum albumin, so it is very specific with this bisphenol A. Okay, so the color changes to violet. Now I know in recent days in Tamil Nadu, people are lazy. In those days, particularly for the construction people, for buying a tea, okay, they used to bring the vessels. Okay, in Tamil, we used to say tukuponi. So they bring the tukuponi, maybe for 10 tea or 20 teas, they will bring a bigger one. But after this, all these technologies are coming, they are very lazy, what they'll do, they'll go to the tea shop, small tea shops, ask the tea shop guy to put the tea in a plastic cover. Okay, so they have now available with the different sizes. Suppose you are saying I want 2 tea, they have a small plastic bag. Okay, so when they put this, so this bisphenol, how it comes, when you put a hard stuff anything to this uh, plastic cover, then they started to melt and cleaving this uh, plastic into giving a product called bisphenol A. Originally, this was identified in UK. Okay, so in UK during 2008 or 9, uh, usually in a winter season, we used to bring a hot water. Okay, we just put a hot water, whatever you're carrying, whether it's a, can or metal, anything. We always want to drink a slightly hotter hot water during winter season. So the same way the kids they put hot water in a uh, can, particularly the like your water can. So they put it, and later they found that some problem with the kids, their their activity. So then later analyzed the water, particularly from that those drinking uh, that cup or drinking that petri, that cans, water cans. So they found that there is a presence of bisphenol A. So keeping this objective, keeping this idea, we want, my scholar, he is interested, so we will try with different materials which is made up from bisphenol A. Again, I used to say, whenever you go to Coimbatore from Dindigul or Madurai, the bus will stop at Darapuram, the place called Darapuram. There, if you go to the tea shop, they will give a tea in a cup. That cup is, very, very, you cannot even handle that cup. It's a very nice cup. That is very cheaper. So that contains, mostly this bisphenol is coming from those type of cups. So my student analyzed. He just add hot water into all these materials, then kept this water for 1 hour. Then he analyzed this compound. If you look at this PVC drinking water cup, that is what I said, small cup. It contains 17.3 nanomolar of this bisphenol after the addition of hot water. Then if you look at the baby's nipple, so that is also, that nipple is also made from some polymer compound that when you put it in the hot stuff, hot water, it dissociates this bisphenol. It contains 12.2. Similarly, in our area now started sambar and kurma, everything they carry on a plastic bags. So if you look at this food package, so mainly the kurma or everything that cover, we found that there is a 20 nanomolar of bisphenol A. Okay. So maybe someone may say that this is only a very low concentration. No, these are all accumulating in your body, and one day maybe you may be suffering from cancer. Then that day, okay. So that is a warning I used to give whenever I give a lecture to the, particularly when I present to the +1 students. Since I was a DST mentor, I used to give awareness. When you tell to the old people, I'm already very old, yeah. Why you are saying like that? I know I have hardly maybe another 5 or 6 years to live. But if you go to the children and saying to the students, they will go and tell their parents. These parents, they are, whenever they something from their kids, they always accept and agree. Okay, so this is the way I conveyed this message, and of course there are many people who have started now stopping all these plastic bags. Even the Tamil Nadu government banned from January 2020 onwards. They banned this all these plastic products, but again it started now. I can see many plastic materials now going around. Okay, so this is a one example of this kind of toxic chemical. So another also, we prepared materials for this pesticide. So this is malathion. I will give an interesting data again to you. So this is the one we collected water from Kasarkod. Okay, Kasarkod, there is a lake. Okay, so this lake, we just collected the water sample from the Kasarkod lake, and we found that it is contaminated with the malathion. Okay, 10 nanogram level. Of course, it is a very small quantity, but still, this lake is mainly because the consumption of many malathion. Okay. So these are all the environmental aspects. Okay, so those who are interested, you can go with the paper. Okay. So the other side which we worked is these electrodes for biomolecules. So far I have discussed about these toxic heavy metals like mercury or pesticides, okay, or polymers, or the organic compounds. So now look at the other things. Okay, this is the one disease called gout. So it mainly comes from the excess concentration of uric acid. Suppose probably I'm consuming the diet. So mainly from the diet, I'm consuming more amount of meat. Okay, then some cabbage. So these particularly, even people used to say mushroom. Mushroom also contains uric acid. So when you consume more uric acid, these uric acid deposited on these joints, and they'll make a huge trouble. Particularly, even we know people from at the age of 40, 45, they are suffering from this disease. So the extreme level of this disease is gout. Then another compound which we commonly consuming is ascorbic acid. So suppose your ascorbic acid concentration you are taking less, then it also leads to other diseases like scurvy, then mental illness, then infertility. Then another vitamin, we used to say vitamin B9, the other name is folic acid. Okay, these are also related with many diseases, including heart attack and stroke. So you need your concentration must be maintained in your blood. Okay, so sometimes you are also getting some psychosis. Okay, then we have some neurotransmitters in our brain. We have these are the compounds transmitting. Okay, so these are the derivatives. So far, 18 compounds scientists found in our brain fluid. So the main compound is called dopamine. Okay, so if you look at this dopamine, dopac, so all these leads to several complications in our body. So one is this dopac. Okay, so we have a neurological disorder and the disease known as Parkinson disease. So what we have done, we have synthesized again silver and gold nanoparticles and attached on these solid substrates electrode. Then I can able to detect this uric acid, ascorbic acid, this folic acid using simple electrochemical setup. So just we coated these nanomaterials on the electrode substrate and we can able to detect ascorbic acid, uric acid, folic acid, even at the concentration of very low, I can say in the micromolar range. Then this dopamine, okay, so dopamine again, detection of dopamine is very difficult. Okay, so you can see I can able to detect all these concentration in a single solution. Okay, so we also successfully detected these compounds in our blood serum samples and also blood plasma and including urine also. So urine also some of the compounds like urea and uric acid. Those things we have done in urine samples. So we just modified this electrode substrate with the different materials, nano materials. Then we can coat it on the electrode substrate to detect these compounds. Okay. So the another objective also we want to prepare glucometer alternative to glucometer because glucometer is still expensive to the particularly maybe now the glucometer is available in Amazon maybe some offer but still I can say that it is more than 1,000 rupees. Then you have to buy a strip. That strip has also some validity of 6 months or 3 months. So we have to find the alternative to this glucometer. So we synthesize the different materials, copper-based materials. So these are copper nanoparticles. We have prepared some dendritic structure. Okay. So this you can see you can make these materials in the laboratory. Then we used this material, particularly this dendritic material. You can see we have a spherical material, then star-shaped material, then this dendritic material. So without the enzyme, I can able to detect glucose. Okay, so you can see I can detect even in the range of something 500 mg, 300 mg, 200 mg. So without the enzyme, so I can able to detect glucose. So still we have some problems with this type of sensor because it is workable only at alkaline pH, that is zero point 0.1 molar NaOH. So how make it this into the pH 7? That is where we are standing. Okay, so this material can be used to detect your glucose both in blood serum. Okay, so you can see blood serum I can able to detect the glucose, but still we have to go long way. We are in the maybe in the middle stage. We have to make a device. We have to make very similar to glucometer. So we need people from the engineering, from the particularly maybe engineering side, how we can convert these signals.
into
Okay, whatever the signal you are getting, how you can make it as a digitalize. I have material. So how to make a device. So I don't have a knowledge in that area, but people from the engineering side, they have a knowledge. Okay, so maybe probably in the future, of course, right now we have a collaboration in Indian Institute of Science. So mechatronics department, we have a collaboration, and right now we are developing sensor for the gout, uric acid. So the same way we are looking for opportunities to uh, go for many sensors. Okay. So far I discussed, probably I will take another 10 minutes or 15 minutes, then I will
Please go,
stop it.
sir.
Okay.
Please.
So the problem with these nanoparticles, it's very nice. Okay, very nice. You can easily detect from your naked eye. Okay, like very similar to your, I said early in my lecture, pregnancy test. It's just changing from the color, you can find it. If you look at the metallic nanoparticle, the problem is the cost. Of course, I don't want to say it's a very much cost, a high cost. Probably for a 3 ml of gold nanoparticle solution, 3 ml, it may be 20 rupees or 25 rupees. So it's not a very high cost, but still we feel that not only the cost, then another issue is less abundance. Okay, so gold, we all know already gold is very precious metal. Its rate is keep on increasing. So we don't want to in trouble with this high cost material. Then another issue is it cannot be reused. Once you use it, you have to throw away. Then if you cannot keep it for a long time. They are unstable, okay, for quite some time. So in order to replace all these demerits, recently we entered into the carbon materials. Okay, so these carbon materials are very cheap. We look at the carbon materials. Only the problem with these carbon materials, they are not color under ordinary conditions. Ordinary conditions in the sense at room temperature or at room light, daylight, it is not, they are not color. You have to irradiate with the UV light. Say for example, I am just passing the UV light, then you can see different colors. You can see here light blue, then blue is blue color, then green color. So you can tune this carbon nanomaterials color by just doping with the different elements like nitrogen, sulfur, phosphorus. So they are very nice colors. Okay. Of course, gold also you have a very nice red color, violet color, but a bit expensive. And I said again, long time storage is the issue. So these carbon nanomaterials, otherwise carbon dots or graphene quantum dots, they are all color in nature under UV light. So you can, the material which we are citric acid, it's a very cheap starting material. Okay, you can easily prepare just heating the citric acid to prepare this carbon material. And of course, now we are all going for green synthesis, green materials. You look at people already exploited all available materials for the synthesis of these carbon dioxide. You can see food source, food and beverage, leaves, waste material. Oh, they have also used the kitchen waste, frying oil, food waste, banana stem, then vegetables, animal. So they have used these materials to prepare these carbon materials. So just they combust it, okay, just heated at some 300 degrees Celsius or 400 degrees Celsius, either making as a juice or a grinded product. They made all these carbon. That one I will show here. So actually this blue luminescent carbon dots is synthesized from melon. Okay, so this is called winter melon. Okay, you can see very nice blue luminescent color. So this is just synthesized from this winter melon, just heated at 180 degrees Celsius. Then that solution was just to put it in the UV chamber. Okay, that is ultraviolet light. So these materials, one drawback is they are luminescent or they are color only under UV light. That is a point I want to make. So just we want to make use of this material to detect one of the compound called tannic acid. This is commonly used in many drug formulations, and also many drinks. So this is a blue luminescent material. We are just synthesized from citric acid, heated at 200 degrees Celsius. We are getting graphene quantum dots. And now see here, the first picture, first the vial, we have added uric acid, ascorbic acid, oxalate ion, glucose, copper, magnesium, sodium, calcium. The color of these graphene quantum dots no change. But if you put tannic acid, the color changes to slightly brownish color. This is under ordinary conditions. That is this is under our room light. But if I keep the same vials into the UV chamber, you can see all these compounds except tannic acid, very nice blue luminescent. But when you add tannic acid, the luminescence becomes non-luminescence. So you can detect again based on your naked eye. Using your naked eye, you can detect easily the presence of tannic acid. Okay, so if you look at all other ascorbic acid, uric acid, they are not changing the color because there is no specific interaction of these molecules with this graphene quantum dots. So this is one example. Now another example I want to show, this is another material called carbon dots. Okay, carbon dots. You can see here very nice blue luminescence. So under room light it is colorless, but under UV light it is very nice luminescent color. Now I have added mercury too. You can see after the addition of mercury too, the color is changes almost when you keep on adding mercury too, the color changes from blue luminescent to non-luminescent. Okay, so if you go back to your gold nanoparticles, it is red in color. When you add mercury too, it becomes colorless. But here only you have to keep in the UV chamber. That is one requirement. Or you have to pass UV light. Like these materials now may be used even sometimes duplication of many certificates and documents. In those days, maybe you can make this material to put a signature. Maybe this signature is not visible under ordinary light, but if you pass UV light, you can find your signature. So that is other area of application I don't want to discuss here. So this is a one area which you can even toxic heavy metal ion can be detected. Okay, so if you look at again here, when I added chromium, cobalt, sodium remains same, but when I add mercury to the color changes. So how we can make use of this material again? In other words, how we can reuse this material? So here I have added potassium iodide. So when I add potassium iodide, this iodide reacts with mercury too. Then mercury iodide coming out from this carbon dots. So now you can see A is in the presence of mercury, it is colorless or weakly colored. But when you keep on adding this potassium iodide, you can see the color again appears. So you can reuse this carbon dots for many repeated measurements. And we also used this carbon dots to sense routine. So routine is one of the flavon derivatives. It is called as vitamin P. So it is present in 70 herbal remedies, routine. So you can analyze this routine using these carbon dots. So again, if you look at when you adding routine, the color changes, but this carbon dots is prepared from different source. So you can see here I can able to detect a routine with 61 microgram per liter. So the same carbon materials can also be used in electrochemical sensing applications. So here ascorbic acid, uric acid, hypoxanthine, xanthine, caffeine. If you look at all these compounds, the common feature except ascorbic acid, they are all coming under purine derivatives. So if you want to detect these compounds in a biological fluid like blood serum, Then you have to use HPLC. So this HPLC is a very costly instrument, and you need a technician. Then you need the preparation of solution. That is very very difficult. It involves tedious procedures for the preparation of standard solutions. So what we have done, we have just taken these carbon dots attached on the electrode surface. Then we can see we individually studied these compounds. So this is the particle which this is the carbon dot particles attached on the electrode surface. Then you can see here, I sense the each compound: uric acid, ascorbic acid, xanthine, hypoxanthine, and caffeine. So this caffeine again, mostly in the when you drink coffee. Okay, so this caffeine is present in the coffee. If you look at using this material, I can deduct all these five compounds in a single run. That means just maybe a minute, just 1 minute, I can able to deduct all these compounds, single run. But if you want to go for other instruments, maybe it will take at least 3 hours, 4 hours, or 5 hours. And another point here, which I want to say, the method is very, very simple. The electrode material which I have used is very, very, very small. Okay, very small. And the cost is very, very cheap. Maybe this electrode may be coming around, I can say maybe the screen printed electrode, it comes around 10 rupees or 15 rupees. Then this material cost is maybe 1 rupee or 2 rupee. So maybe within 50 rupees we can make. Of course, maybe when you go for application practical, there are some difficulties, but we can overcome. The only if we combine with people like engineering people, they know how to solve all these issues, drawbacks. Okay, right. So I can also able to deduct even small concentration, very low concentration in the presence of high concentrations of other compounds. Okay, so this is what right now we are very much concentrating in our laboratory. How we will make use of these low cost materials into devices. Okay, so we have support from DST under product development, biomedical technology. Of course, there are 4 institutes involved in this project. The principal investigator is from Indian Institute of Science, and we have 3 other institutes collaborating with IISc. One is Gandhigram Rural Institute, the other one is Sekri Karaikudi, and the third one is VIT Velu. Okay, so these 3 institutes are expertise in chemistry. Okay, the principal investigator from IISc, he is expertise in developing the software and also these devices. So he already developed many sensors. So right now our work is mainly concentrating on developing sensor for uric acid, that is gout disease. Okay, so this was very recently published, just last month it was published in Journal of Material Chemistry B. So those who want, you want more details about this work, how we have sensed all these compounds, maybe you can, the details, maybe you can get it from this paper. Okay. So to summarize my presentation, so just my first part, almost I've given representative examples. Like, of course, we have developed many sensors. So due to the lack of time, I have given few pesticides, few heavy metal ions, particularly heavy metal ions. I have taken only mercury 2. So you can deduct these materials very easily from our naked eye. Then the last 10 minutes, just I have introduced these low cost carbon materials, how we can make sensors. I hope that in future we will replace all these metallic nanoparticles with these carbon nanomaterials. Okay. So again, I'm very happy. I'm very much thankful to my students, my PhD scholars, whatever I'm presenting, because of their hard work and their sincere works. Of course, in
It is
sitting
the
in
other way.
Gandhigram.
It is the other way, Professor. They are getting benefited. They are getting knowledge
Okay,
from you.
okay.
Please,
So look at all these spaces, they are all,
brilliant.
Gandhigram state is benefited because there are many rural students. We are getting many rural. We are not getting creamy students. So look at all these, all of them are first generation. Okay. So so far I have completed 18 PhDs, all the 18, okay, of them from the first generation. So of course, some of them are settled in abroad. The first person, Kalimuthu, right now he's working in GRI. Of course, he was in abroad for quite some time, 2 or 3 years. Then the second one, Kalimuthu, right now he's in Queensland University. He's working for there for last 10 years. Then Sivanesan, he was also settled in Australia. And Kannan, I think he was associate professor in China. Of course, there are few of them got permanent position in India also, and of course, the other acknowledgement I must acknowledge the funding agencies. Again, Gandhigram Rural Institute. To be frank, they are not. We are not getting any financial support, of course, for research. Okay, but the funding agencies which are generously supported for my research is Department of Science and Technology. That is where my first project. That was hardly 9.5 lakhs, but that made me really because that is the first project I got, and of course this time I also want to thank the head of the department that time, Dr. Karthige. Okay, so he encouraged me, and he, of course, he has given all the money for whatever the overhead charges. I have fully utilized it to buy small things. So I also thank the other funding agencies like DRDO, DBT, UGC. So my thanks to all the participants today. Of course, I know it's a very hard time uh, during the lunch time. One way I can say, even you can eat and listen the lecture. That's why we are benefited by this COVID-19. We can have a meeting at any time. Anyway, thank you very much. Thank you very much for your patient listening. Thank you.
Professor, I should recall my days when I was there. I have seen you when you joined. I was a very small boy, and you were with Dr. Karthik, as you have rightly taken his name. Dr. Karthik is no more with us, but his memories are always there. Uh, the same Professor John Abraham was lecturer John Abraham at that point in time. The same smile, the same
Okay.
style, the same style, because my sister used to tell this, the same style, and a layman type of chemistry professor like me can understand what you are saying.
That's what, because it's
Very
heterogeneous.
simple language, very
I don't
simple
want to
language.
put all chemistry. Otherwise, people
It's
may
a
apply.
very simple presentation, professor. Really, it was very informative, rather, I should say. Uh, this is what is Gandhigram, showcasing that yes, the students, their brilliant faces. It was wonderful. It was wonderful, professor. And the kind of research activities you have done is commendable. No doubt about it, professor. I'm sure the student fraternity has got a lot from you, and you are a leader. You made their career.
Thank you.
It's
Thank
how
you
it
for your
is.
compliment.
Mm, this presentation you can unpin now, so that we are able to.
Okay, okay, okay.
So
Yes.
that's the fifth day webinar series which we had you as a chief guest to deliver a lecture on a particular title, and it's simply, in cricket language we say, all the balls were above the roof of the stadium. Thank you so much. Thank you so much, Rosa. It is now the My turn to ask one simple question. I have only one question. As a layman, I will
Okay.
ask this.
Okay.
Professor, with low-cost carbon nanomaterials for sensor application, what is in there for the student fraternity? What is in there for the institution, and what is in there for the country as a whole?
I don't know. I don't get into your question.
See, my question is very simple. My question is very simple. This low-cost carbon nanomaterials for sensor application, how does it help the individual students in Gandhigram University?
Individual students.
How
Okay.
does it benefits the institution
As a
as a
in country also.
yes,
Okay. Okay.
and as a country?
Yes. Yes. So again, a single point. It's a waste wealth. Okay, waste. So if you look at the carbon materials which we can synthesize is from even from the waste. That's what I have give. I have shown one slide. Even you can use the oil, used oil. From the used oil, you can prepare the carbon dioxide. Then use the paper materials, you can prepare the carbon dioxide.
Hmm.
Okay, so the source again from the waste. So you are again from the waste to wealth. Okay, so then the next is how we can make all these. We are all after all for the people. Poor people. We have to giving a good health system. Okay, good sensor, cheaper sensors. Even maybe like the government of India is now looking for giving a free COVID-19 sensor. The same angle each student must think, each countryman should think. We should somehow we have to benefit to the community. So whatever you are doing in the laboratory level research must be transferred to the society. So that is one objectives of the Gandhigram Rural Institute. When I joined, so I could see the board from our laboratory outside. So something, whatever you are doing in just in the not laboratory level, it must be transferred to the community. So, but as a student point of view, I think again, they have to work hard. Then they have to find, how we can transfer, because all these technologies are all coming. Nowadays, students what they feel that getting a job, settling in that kind of things must be changed. And also everybody should take something like a pledge. So we should contribute something for this country. That is I used to tell my students, really, if you work hard, you will get later you will be benefited.
True.
If you are lazy and if you are not working sincerely, then later you will not be settled down. Okay, that is a simple mantra I used to sell. Don't look at the society. No, they are asking money or they are something like. Don't complain the society. Everybody is perfect. Everybody is sincere in their work. Then automatically. Thank you.
People will recognize the knowledge what you have acquired from the institution, from the seniors,
Yes.
from the professors and the lecturers. This takes a lot. When I used to give some lectures in the management students thing, someone asked me, sir, what I should do and what I should not do, or what is right and what is wrong. My simple answer was, whatever you do is right and whatever you don't do is wrong. Simple. You keep it like that. Don't break your mind. Understand from the from the professors the concept. My father used to tell, yes, the concept should be understood, and once you are able to understand the concept and grasp it and develop it on your own style, you are a scientist. This is how.
Yes.
This is how I saw many people. Gandhiram is a very small uh, nuclear family, professor. So you can have anybody's picture at money tea stall. So the students fraternity where they were standing together, they used to speak. John sir is very heavy taskmaster, but it is not a complaint. It is a motivation, rather. Right? And those people, wherever they are, the Gandhigram Rural Institute is close to their chest.
Yes. Yes. They are our ambassadors.
Yes. Uh, this is what the reality is. I am really thankful to you, Professor. You have taken your valuable time from apart from your work. you have taken out really very valuable time and you have contributed to our webinar series. I'm really thankful to you, Professor. This should be it should be a beginning. I should have Professor John Abraham time and again for different subjects is what my wish is. And I thank you for being with us in this afternoon, uh, in spite of your very busy schedule. Thank you so much, Professor. Jai Hind.
Thank you. Thank you. Thank you.